within the volcanic islands of Papua New Guinea, an international team of scientists is embarking on a groundbreaking mission.
So you're still trying to finish?
Heading up the team is eminent coral ecologist Dr. Katerina Fabricius from the Australian Institute of Marine Science. Nestled amongst the pristine waters of Milne Bay, Katerina has found a reef that may hold the key to understanding one of the world's most pressing problems: ocean acidification. Amazingly, these bubbles are pure carbon dioxide coming directly from the Earth's crust.
We've got a lot of volcanic activity, and the volcanoes produce carbon dioxide that are emerging from the seafloor here in shallow water where coral reef is growing. So it's an absolutely unique site to study the effects of ocean acidification, and it's a site like nowhere else in the world.
Since the Industrial Revolution, 30% of all carbon dioxide that's in the atmosphere has been absorbed by the ocean. As the levels of CO2 continue to rise, the seawater chemistry is changing, making the ocean more acidic. This spells disaster for any marine life with a shell or skeleton, such as coral.
The reef is made of calcifying organisms, so that means they need a higher pH to be able to build their skeleton. And this skeleton then provides the structure of the reef where all the other associated species can mate and they can feed and they can hide. When the pH is lower, this structure starts to dissolve and erode.
The level of CO2 at these sites is providing the scientists with a unique window into the future.
Science is pretty much like a detective story. For example, we want to know why are certain organisms quite happy and abundant at the high CO2 sites and why others are missing.
Far from home, they must be resourceful and inventive. Sometimes it doesn't always go to plan.
Little nubbins we created had Dropelia snail feeding all over them. It's like dinner served up on a plate to them.
There are many questions. Will biodiversity change in a high CO2 world?
I'm searching for the crabs and the mollusk, and here is a little ophiurid trying to escape. So we're all part of a chain here, and if you miss a link in the chain, the rest of the chain can't go on.
DNA barcoding at the Smithsonian will provide answers. Is the water chemistry too hostile for baby corals to grow? The results from hundreds of settlement tiles will tell us. In lab experiments, these clownfish lose their sense of direction as the water becomes more acidic. Will the same thing happen in this natural laboratory? One thing is clear. In this environment, seagrass is a winner.
For anything that eats seagrass in the future, the world looks quite rosy.
The locals are fascinated by what they see and keen to understand what's happening to their world.
The coral reefs will still be there in 50 or 100 years' time, but they will look very different, is our prediction.
It's not only coral reefs that are in jeopardy. Polar seas will be hit first and hardest. With less available calcium carbonate, will tiny creatures like pteropods and krill that are a critical part of the food chain crumble and disappear. 4 out of 5 of the last mass extinctions on our planet were due to spikes in atmospheric CO2. Are we heading towards the 6th mass extinction?
We've started answering a whole heap of questions about the very fundamentals of how coral reefs are working in high carbon dioxide environment, which is very exciting and very special.
Join us as we investigate how ocean acidification may change our world if carbon emissions continue to rise.